Thank you all for joining us. Our host today is Mr. Vincent Baril, an alumnus of IFP School, class of 1989, now the chairman of Shell France and general manager for sustainable chemicals. Thank you very much, Vincent, for accepting our invitation so warmly. We will see you soon. Today's subject is carbon neutrality. This subject could be quite common today, but Vincent will explain Shell's scenarios to meet the goals of the Paris Agreement. Our webinar will be in two parts, a 10-minute introduction of the subject by Vincent, and then 10-minute Q&A session. This will be followed by another 15-minute presentation and second 15-minute Q&A session. Please raise your questions in Zoom's Q&A section and feel free to share any comments in the chat. Our support team, Joao, Sabine, and Mei-Ling, will be glad to interact with you and share your questions with Vincent. The recordings of this webinar will be shared with you in the coming days. Vincent, I've spoken too much. So can you please introduce yourself and perhaps share with us a special memory of your time at the school? The floor is yours. Thank you, Vincent.
Thank you very much. Yes, so my name is indeed Vincent Baril, and for the francophone in the audience, it's always funny to have this name and to work in the oil industry. I can tell you it has been a series of good jokes about my names, and at least everybody remember my names, so that's okay. Yes, indeed, I was at the ESPM at that time, the predecessor of the IFP School, and I used to say that I was at that school 20 years plus ago, but you were reminding me that it was indeed 31 years ago. At least it was at the time where, and I don't know if it's the same now, but at the time where all the oil company, Total, Shell, BP, Exxon, went literally to the school to hunt the students and offer them a contract immediately. And so I had to make a choice between the different oil company. And I put a very sophisticated decision process. So Shell offered me a job at Berre near Aix-en-Provence, Total in Dunkirk, and Exxon in Notre-Dame-de-Gravenchon. So you can imagine how quickly I fell in love with Shell to go to the sun. So that's how you make a choice for your career at the beginning. And it was good because I spent 30 years in Shell, first in the plant, in the refinery, petrochemical plant, then moved to Paris for the M&A, so merger and acquisition department, and then flew for 20 years around the globe to Singapore first, London, The Hague, Singapore, and even Australia and The Hague, I think another time, so for 20 years. And 4 years ago, I came back to Paris to take the lead of the Shell France. So that's in a nutshell my 30 years in this business, most of the time in chemicals, and now I'm also we have two double hats in Shell. Usually, I've got also the global responsibility of sustainability for chemicals. So today we are going to talk about scenarios by Shell. Shell has designed scenario for the last 50 years. But today we are going to specifically talk about the Sky scenario, which is, it was published in 2018, I think, yes, 2018, 2 years ago. And it is an illustration of a technically possible but challenging path forward for the society to achieve the goal of the Paris Agreement. I'm sure you all know what the Paris Agreement are, but that's the I think that's the COP21, and a lot of countries, most of the countries and the nation in the world agreed to take action to limit the global warming to 2 degrees C that has been reduced to 1.5 degrees C a few years after. Okay, so I try to change slide. I hope it works. Let me check that. Yes, so that's the most important slide, and I hope you can read that very quickly. What it means that we will stay friends even if everything I'm going to tell you will never happen. So that's just a disclaimer, don't worry about that. Okay, scenarios. So why designing scenarios instead of going for forecast? So I can tell you, because in Shell, we have been forever trying to predict and to forecast the oil price. And I don't think we have been successful 1 year. So now we change that. We don't do any forecast anymore. We just work with scenarios. What are scenarios, to be honest? Scenarios are based on building blocks that could be discussed and change in future. And that brings much more perspective to the result. And it's really the Shell scenario asks the what if or how questions. And they are not prediction nor Shell business plan at all, but they are a realistic tool to inform dialogue. So when Shell wants to dialogue with authorities, with customer, with supplier, we always use the scenario that gives a good platform for a constructive discussion. So from that, what are the main scenarios? So as I told you, Shell has been designing scenarios for 50 years about, and we look at social economic pathways like the mechanism to share common interest, which means are the nation going to work together or not? And strength of leadership. Does it mean people want to do something or are not too interesting to do something? And you've got 2 scenarios that are mountains and ocean. And these 2 scenarios take very fixed building blocks, like for mountains, poor interest to work together, but a lot of leadership. And the level of emission of greenhouse gas is an open-ended result from this scenario, and same thing with ocean in a different perspective. Sky is very different. Sky starts by a level and fix a level of greenhouse gas emission that need to be respected to achieve the Paris Agreement, and then move backwards and try to define the different building blocks that needs to be in place if we want to achieve the Paris Agreement. And that's the sky scenario that I'm going to really detail a little bit with you. We will see the result of the mountain and oceans scenarios at the end of the presentation, and you will see it's very different. So the sky scenarios has, with this back calculation, has put in the light 6 big building blocks or steps that we need to have in place if we want to reach the Paris Agreement goal. And these 6 big steps, I'm going to give you a high-level view now, then we will stop before we go in details to each step. So the 6 big steps are a carbon pricing. That means we need some stick to incentivize the reduction of CO2 emission in the atmosphere. Energy efficiency, that means we can't continue to live with the same level of energy demand per habitant in a world that in a world where the population is growing fast, and also the big part of the population is going to be developed, which is a good sign. But when we develop the population, when the population develops, it requires and asks and need much more energy. So if you put that together, a growing population plus a more developed population, you achieve a level of energy demand that is not possible with and not in adequation with the Paris Agreement. Then third one is electrification, and we all understand why, because electricity will be the main vector for green power. And of course, if we have electricity, we need to have the green power, which mainly would be the wind and solar, and we need to grow this system very quickly. Unfortunately, the timeline is very short. Even if we talk about 30, 50 years, it's very short to change completely an energy mixed. And the growth in the green power is not going to be fast enough. So we need to put some CO2 underground and use the carbon capture and storage. And the biggest CO2 sink that we have on the planet is the forest. And definitely, if we put some CO2 underground, we need to stop destroying this forest. That is a really good natural CO2 sink. Overall, in these 6 steps, we need to have something which is absolutely essential, and you have seen that in the slide before, that people need to cooperate. So that means nations, industry, and consumer need really to work, to be aligned on the effort to do. That's also the leadership, and need to accept a really big change in the way of living in this planet. So let me stop here. Maybe you have already some question, and after that, I will go in much more detail in the carbon pricing, et cetera, and I will even show you some energy mix of the future. That's the slide everybody wants to see.
Thank you very much, Vincent, for this first part. Yes, there are some questions.
Good.
First one. Sorry, I can't read it. Yes. So the first one is, what about the impact of the upcoming USA presidential election results toward the goals of the Paris Agreement? So this is a very general question. And so what do you think? Could you be an impact?
Yeah. Yes, so the impact, as I said, it's a scenario. So we review the scenario every, I don't know, I think it's every year, every 2 years, and we adapt the scenario for the different impact. With Donald Trump, for instance, he refused the Paris Agreement, so he withdrawn from the Paris Agreement, which is an impact on the willingness for the nation to work together, and that will have, depending on the future president, we will update that. However, for the US president, his impact on climate change is not that big, to be honest. Why? Because in the US, as you may know, the different states have their say. And for instance, California is probably one of the most advanced country in terms of sustainability in the world, for instance. So yes, at the federal level, that has an impact, but in practice, not that much, to be honest.
Yes, of course. A second one, perhaps generous. So, how technical skill requirements have changed in energy industry in post-COVID world?
You will see that COVID is, of course, a big building blocks that was not foreseen 12 months ago. We haven't. You will see in the rest of the presentation that this scenario hasn't been updated with the COVID situation. I think we will do that when the COVID is will be over, and I hope very soon. What the impact on the COVID? Well, today we can see that people probably a kind of speeding towards goal zero, fastening the growth of the new energy systems. Definitely a positive impact towards carbon neutrality.
Yes, okay. And perhaps another one for this first part. Why are you showing 2070 when referring to Paris Agreement target should be reached in 2050?
So that's a very good question. Paris Agreement, yes, target should be reached in 2050. So we work to design these scenarios. We have teams in Shell who set up the assumption, the things, and everything is computed by MIT in the US, and with plausible pathway in terms of speed of change in the society, etc., etc. It looks like, because nobody is certain and nobody knows what will happen in 30 or 50 years, but it looks like it is difficult to achieve the carbon neutrality in 2050, and that we might need few years to get to that point. But what is important is the temperature elevation or increase, and we will see that we can reach the 1.5 or 2% or 2 degree increase.
Okay. Oh, thank you very much. I think that we can go on the second part because the other questions are more specific for the second part.
Okay, no problem. So
Thank
carbon
you.
pricing. So I said, if you don't incentivize people to reduce their CO2 emission, and money is the best way to do that, they won't do it. Today, everybody knows that carbon pricing is very low to almost inexistent. This is the path, the trend that we foresee to be needed if we want to get to carbon neutrality. You see at the end, it's $200 per ton of CO2. And you see for an oil company like Shell to show these kind of numbers, that really needs a bit of courage. But this is a scenario, and this is what we see to be necessary if we want to achieve carbon neutrality in 2070. So that's the first one. The second one is energy efficiency. So I said global population growing and developing, which is very good. However, we need to increase our efficiency, energy efficiency. Otherwise, the absolute level of energy is not going to be, we're not going to be able to produce this level of energy with enough green power, and we will need too much of the hydrocarbon, and we will miss the target of the Paris Agreement. Couple of examples of energy efficiency. Yeah? So if you look at the second one, the car. So 50 years ago, basically, in the last 50 years, we have increased the level of efficiency, of energy efficiency of a car. We have doubled the efficiency of this car. But if we want to really reach the Paris Agreement target, in the next 50 years, we need to triple from where we are today. And that's, again, because we need to save the energy, because it will be difficult to supply all this energy in a decarbonized way in the future. And we need to also be careful of our behaviors. If you look at the last one, the light. So with the LED, we have made huge progress in energy efficiency. The only problem is we still maintain the demand on energy for lights, because we consume as consumer, we consume less, it's cheaper, and then we put more lights. We lighten our gardens, we lighten more things, and this is not the way we are going to achieve carbon neutrality. We need to keep the same level of comfort, but with less energy, basically. Step 3, so electrification. This is the increase in terms of electrification, and if we continue the trend, you see the dotted lines. The dotted lines show you something which is linear. In fact, with this scenario, we need to really almost, or at least, sorry, not almost, at least triple the historic rate of electrification. So there is a complete step change to happen in terms of electrification, and that's not going to be cheap, and that's not going to be easy, to be honest. You can have the same thing, a bit more detailed in terms of industry, building, and transport. So you will see the transport is moving fast on electrification, but building and industry as well. This is the slide that everybody expects. What is going to be the energy mixed? Once again, this is not a prediction. This is what we need to have to reach the Paris Agreement targets. The first thing you see is that at a global level, we will still have oil, gas, and coal. Much less than today, of course. The reduction is quite impressive, but we still have, at the end of the century, some hydrocarbons. And why that? Because it will be very difficult for developing countries who are rich in this resource to avoid using their own resource for energy. The second thing is, you see the big winner is solar. Why such a big increase in solar? You can see the potential. For instance, if we put solar panel on every houses, every buildings in the world, you have a huge potential to electrify housing, and that will have a big impact on the energy mix in future. There is another way to look at that. This is the same slide, but in different things. So on the left side is today, and then it's 2070, so in 50 years. And you can see the different, first, the different in terms of absolute numbers. So the size of the wheel in 2070 is much bigger. But also coal, for instance, which is almost 30% of the energy today, is going to reduce to 6 only. And solar, which is nothing today, is going to be 1/3 of the total energy mix in future. So these two graphs are global. If we want to look at Europe, then you see something very different. You see that coal and oil will disappear in Europe. Gas will still be there for a while. And then it's more or less equally spread around the bioenergy, which is very important in Europe, as well as nuclear, solar, and wind, basically. So that's something very different picture from Europe base compared to the global one. So I said again, the cast, this is what is in the scenario today. So basically, the coal peak was potentially in 2014, oil peak in 2025. I know BP said it's now I don't know. Natural gas will plateau for a while in the 30s. You can see clearly in these graphs that the COVID impact hasn't been taken into account at all. So that will be updated probably in 2021. Okay. Yeah. Okay. So as I said, and you probably understand that very well. We need some carbon capture and storage, and why that, and why it's going to take a big growth in our view. First of all, because it's a technology that is mature. We know how to do that, especially the oil company knows that. And the green power, electricity, whatever, hydrogen, etc., that is going to be produced is going to be allocated in priority for mobility, for instance, because the nation, the authorities are going to allocate that to mobility because it's very visible when you put that to mobility, and people are voters as well. So it's most likely that the green power will go in priority to mobility, but the industry, for instance. It's easy to capture. It's a very concentrated stream of CO2, so it's easy to capture. And then we can transport even far. A pipeline exists, and put that on the ground, and block it for forever, and reduce drastically the level of CO2 emission in the world. Last one, of course, is deforestation. As I said at the beginning, forest trees are the biggest natural thing that we have. And we see at global level a reduction of the forest, and we need to stop that because it doesn't help at all. So now, what is the result in terms of temperature rise? Huh? You see the history rising sharply. Sky doesn't give you 1.5 in terms of 1.5 degrees C in terms of rise, but something like 1.7. And the other two scenarios that we have studied give you something more or less around 2.5 degrees C. So you could tell me, surely, what can we do if we want to reach the 1.5 temperature increase by the end of the century? So what we can do is to work on nature-based solution, what we call nature-based solution, which is forestation. So we can plant trees, because that's a really good natural thing for CO2. And if you plant trees, normally I've got an animation here. So if you plant trees, you reach the 1.5. However, how many trees do you need to, and how much forest you need to plant to get to this level? Well, you need to plant trees on a surface which is equivalent to the area of Brazil. So that tells you the huge work that you have to do if you want to reduce by half a degree just by planting trees. So it's interesting. We need to go to the end of the century if we want to see the 1.5. If you want to see the let's say the 1.7, etc., and a big inflection, we need to start now. And you see that in 2050, we're probably not there yet, not too far, but we need to continue the effort for a long time, and an evergreen change of behavior in our planet. So that was the end of the formal presentation. Of course, everything is transparent in Shell. If you, and I'm sure some of you would like to review the calculation, the numbers, everything is definitely available on our website. You have all the huge spreadsheet. You have all these scenarios that are details in the website, and we have even a leaflet, a book on the sky scenario that explains in much more detail what I told you in 20 minutes. So I really, if you want more details, you can go to that one, and the spreadsheet are really the spreadsheet that the MIT is computing for Shell. So on that note, I like to open again for Q&A.
Yes, hello. So thank you, Vincent. So we have many questions so far for you from our attendees. So difficult to choose, but in general, perhaps another energy about nuclear. So Jean Covici is promoting nuclear instead of solar and wind energy. Does Shell study this scenario? What is your point of view about nuclear energy?
So, in fact, when we design the scenario, we are completely agnostic about the energy and whether we like it or not in terms of result. We just it's a modelization, and we look at that. So in the for the nuclear energy, the assumption, and I can't give you the whole assumption, is that yes, indeed, nuclear is a carbon neutral energy. However, it's not widely accepted as an energy, and we have put that as an assumption in the calculation. So that means the nuclear cannot grow completely freely because there is resistance from population to nuclear. In some country, and you have seen that in Europe, there is quite a good part of nuclear in the energy mix.
Another one, perhaps benchmark. How do you compare Shell views with BP Outlook and International Energy Agency Outlook that were published in the past few weeks?
Yes. So I don't have the details of BP. I saw their outlook. I know more about the International Agency. The big difference between the agency and Shell is the absolute level of energy demand that is forecasted. So in Shell, we really forecast. We really have absolute demand of energy which is high. And the highest you have it, the more difficult it is to decarbonize, of course. I know that with the International Agency, they have an absolute energy demand which is lower, and therefore it's easier for them to decarbonize. But that's a good question, because the absolute level in terms of energy demand is probably the key assumption in that one, and we calculate that based on the population growth and the developing country growth rate as well.
Yes, okay. So there are many, many questions. Perhaps another one. Can you give us some figures? So as a company, to what degree is Shell planning to divest from fossil fuel production?
Divestment in fossil fuel. Yes, so we have yes, we have done that already. When the so, for instance, we divested completely the oil sand field that we had in Canada, and one of the reasons for that is that the CO2 life cycle analysis of this oil sand was very bad, and it was divested. Today, not a lot of people know that, but today we invest less than 50% into oil in Shell. So we make a lot of steps to move to new energies, and we have a target to become carbon neutral latest in 2050 and not 2070 like in the scenario. So for us, it's 2050 or earlier, if possible. So that's our net zero ambition indeed.
Perhaps some questions about hydrogen. According to Shell, what is the role of green hydrogen in the carbon neutrality target? And what is the ambition of Shell for green hydrogen?
So in Shell, we believe in hydrogen for two reasons. Hydrogen can be used for sectors that are extremely difficult to decarbonize. So heavy transport, for instance, marine and heavy trucks, but also can be used as energy storage. So at some point, we will have to, the world will have to build solar farms and wind farms very far from where the energy is consumed, and you need to store and move this energy, and hydrogen could be a good way to do it. So we believe in that one. We believe in hydrogen. We are developing hydrogen. We have a lot of hydrogen business in California, for instance. And why in California? Again, very important. It is where the country, the industry, and the consumer are aligned on hydrogen. There's some help from the government. The industry is moving there, and people buy hydrogen cars, for instance.
And will Shell prefer blue or green hydrogen to deliver the industry?
Well, we need a lot of hydrogen, to be honest, and green hydrogen is ideal, and we have project to build a big electrolyzer in the Netherlands, linked to the offshore wind farm that we are building. However, we need to go fast, and if you have blue hydrogen linked to a CCS, for instance, to carbon capture, it could do the job as well. So we prefer the green hydrogen, but practically we might need a bit of blue hydrogen as well, especially for the industry.
Okay, and perhaps one more about hydrogen, the natural hydrogen. Is Shell investigating and exploring the natural hydrogen?
I don't know. I don't think so. And I don't really know, and I'm not completely aware of the potential of natural hydrogen, to be honest.
Okay. Perhaps let's go to electrification. That was the scenario. Electricity will be the main vector of green power. What do you think? So you answer a little bit about it, but
yes. Yes, of course. I think so.
Yeah.
We can't. It will be difficult to do achieve the carbon neutrality without a big share in the electric mix in terms of electricity, which will be difficult because that implies a lot of investment in the infrastructure for electricity. So electricity is going to be difficult. Just for so the Shell station, retail station, for instance, have charging, EV charging. They are equipped with EV charging, fast charging. If you have 5, 10, that's okay. If you want to have 200, you need a huge electrical infrastructure behind that, and that's very expensive. So it's going to be expensive, but it's needed.
Okay. Perhaps another question about carbon price. Do you have views on the CO2 pricing required to get the signal for a wave of CCS project? Is there a link?
Yeah, I think.
What is your vision? Yeah.
So CCS project. So it's yeah, it's a bit difficult. The putting CO2 underground is not expensive. What is expensive is the collection and the transport. Sometimes you have to build a pipeline for 100 kilometers or 200 kilometers. And depending if the source of CO2 are very concentrated or not very concentrated, the cost might be very different. But something around $75 per ton to $100 per ton will definitely move CCS as something very, in some cases, very economically viable.
And what about exactly by Shell? Is the availability of efficient storage for energy has been identified to be an important step by Shell? Do you have already identified? Yeah.
Yeah, we have several CCS projects already working. So and we work, for instance, we work with Total and Equinor on a big one in the North Sea. We have one already working in North America, and we have also one or two in Asia, and we are studying 4 or 5 on that one. So there are storages, and usually we can have a lot of CO2 reduction by CCS indeed, especially for the industry. That's very good.
Okay. And perhaps a final one, because there are so many questions. Thank you very much to all of you. The timelines for implementing the 6 steps seems to be different. How can these timelines be reconciled in terms of regulation, international cooperation, markets building? How do you manage the time?
So, as I said, the timeline depends on the assumption that you put in terms of ability for society to change, and if you see, for instance, building a offshore wind farm in France, between the beginning of the tender and the starting of the offshore farm, you have usually 10 years. So there are things you can't compress. You can't say, I will have 1 gigawatt of offshore wind tomorrow, because it takes time. So all this timeline and all this assumption in terms of ability to change are in the model. Come with the model, and you can discuss with the authorities. And you can say, well, if you don't decide today, you can't have what you want. And we do scenario for a lot of things. We just finished a scenario for the city of Paris, to be honest. We worked that and for decarbonization of the city of Paris. And that's a very good tool to discuss with the city on action to take, when to take it, how big, how far, how ambitious should they be to do that. The sky scenario is exactly the same. We can discuss with the EU Commission with the sky scenario, and of course we don't say that it's a prediction, it's a forecast. We need also to bring the BP scenario, the International Energy Agency scenario, and say the truth is in between, but definitely they have all the same trend, and they can be a very good basis for discussion, especially for authorities. And it's going to be difficult. It is plausible, but it's going to be difficult. And I think for politicians, at some point, it's going to be painful, because it requires quite some investment and money.
Okay, thank you very much, Vincent. I think it's time to, for the end right now, perhaps a final question. So you have to face so many challenges as Shell CEO. How IFP School prepare you for all these challenges?
Hey, yes, that's a good one. I was in the what they call at that time raffinage, so it's process engineering. So I studied process engineering. I think the IFP school gives you more than the thermodynamic course that I followed. It's more the agility in thinking. It's the definitely the logic that you need to have, and how you bring challenges on the table, and how you also can adapt yourself. Because if you can't adapt yourself, how can the world around you adapt itself to something, a huge challenge like the carbon neutrality? So no, I absolutely don't regret the year I spent with ISP School. Don't worry.
Thank you very much. So it was a real pleasure to listen to you, Vincent. And again, thank you very much to all of you. I think that the discussion was very rich, very vast. There were so many questions. So you can send us your feedback to alumni IFP School at ifpendpoint.fr. It will be very useful for us. And in order to follow IFP School news, so we hope to see you soon at our next webinar on December 8th of December 2020 with Mr. Jean-Marie Laigle. He was IFP School in 2004, and he will cover the subject: how does big data contribute to the renewal of sedimentary basin exploration? So it will be at the same time in 1 month. And so once again, special thanks to you, Vincent. Thank you very much for your time, for the presentation, and all the questions that you answered. Thanks a lot.
Thank you very much for inviting me.
Good evening, everyone. Bye-bye.